Found the right switch. Okay, sorry about that, everyone. Here we have Matthias back with us.
Okay, now thanks again, James, for this nice introduction. I'm Matthias. I'm the lead developer of Spray, and I'm glad that so many of you have joined us today for this talk on Spray and Akka. One thing, right before we get into the content, there is a link on the first chart that you can see right now. And if you click on that link and open it up in a second browser window, you should be able to see all the charts that I'm going to lead you through right now on your screen, and you can freely jump between pages. This is important because on quite a few charts there are links. They are all the blue ones, and you can actually click through to content that I have linked to and give you some background information and so on. So let's get started right away. What is Spray? Some of you might have used it before, but I guess many of you don't know really what Spray is. And Spray is essentially an HTTP stack for your Akka or Scala applications. It's embeddable, so it's not a standalone server that you deploy your applications in. It's a library component that you just tie in to your application like any other library, and you can just use it for anything that has to do anything with HTTP. The focus of Spray is HTTP integration layers, as we call it. So it's not so much for building web applications, even though you can do that, but it's more for building integration layers, meaning that if you have an application today, it usually doesn't live on an island, but it has to communicate with all kinds of other applications, be it Twitter, be it Facebook, be it a weather API or anything else. So either from the server or the client side, you many times need to enable access to other consumers of your business service, for example. And this is done with HTTP in many, many cases, because HTTP is actually the most important and most successful integration protocol. You can use it basically from any language, and any client can communicate with your service if you give it a REST/HTTP API. And to enable that, that's what Spray was made for. So it's a server and client-side thing, which also sets it apart from many other HTTP implementations, which many times only focus on one or the other. So some of you might ask, why? Why go through the trouble of building something, an HTTP stack, completely from scratch in Scala, when there's actually when there are actually all kinds of solutions already available for that? So can we just use something like Netty, or servlet containers, or RESTlet, or Undertow, or one of the many other server and or client-side HTTP implementations on the JVM? And we have to say, of course, we can. Yeah, it's been done all the time. Actually, I think, as far as we know, Spray is actually the only HTTP implementation in Scala that is really done in Scala. All the other ones, and there are many servers that you can use, like Socko or Play, of course, they all internally rely on a proven, so to speak, Java implementation of HTTP. And the question is, why don't we do it? We say, well, do we really want to rely on these existing technologies? And from a Scala perspective, I'm speaking from a Scala perspective here, I would say we don't really want to rely on them. Well, why not? Many of you will know servlet containers, or for example, for server-side HTTP, and you might realize that they're not always the best answer. They're proven, but they're really old many times, and it shows in the APIs, it shows in the ways that you manage these kind of components. And sometimes people say, we don't really need a servlet container. Can't we have something more lightweight? Do we really need to configure everything in XML? Can't we use something like JSON or a more modern kind of configuration tool? From a Scala perspective, the mutable data models and mutable APIs that oftentimes are the basis of the Java side HTTP implementations, they're not that attractive because they conflict with the programming model that you often find in Scala applications. And then, as a Scala developer, many times the Java collections are not as rich as what we are used to on the Scala side. You can use them, but you need adapter layers, which add complexity and add overhead. Sometimes not what you want. And of course, from Scala, we are used to a very rich and powerful type system, which is not really leveraged by legacy APIs. So from a Scala perspective, even though we say the proven technologies like NetI and so on are great and they're performant, and those guys definitely know what they're doing, but they're just lacking if I look at them from a Scala perspective. What we really want when we come from Scala, we want case classes. That's what we are used to. That's what makes it easy for us to work with data models. We want actor-based APIs if you're building an Akka application. So rather than method calling, you want a message protocol where you say certain messages are being sent around between your actors. And if you have an API from a library that supports that programming model, then that's much more natural for you. Functions as values are something that we're used to from the Scala side, which are nice to have also on an API surface, because it makes many things much easier. And of course, we have Scala and Akka futures that we've become used to, which are great. The Scala collections, as I already mentioned, are much more powerful and richer than their Java side counterparts. And then we have additional things like the type safety, as mentioned, and type classes, which you might not know, but it's not important. Once you've been working with Scala for some time, you'll come to like them as a great tool for decoupling logic and really keeping things testable and nice and well compartmentalized. So you could have everything that I just said, but just adding an adapter layer around NetI, for example, where you bury all this, let's say, legacy API stuff underneath some nice and shiny Scala adapter layer that gives you everything on top, and you can just use it. But there are other things that we want which are not possible to achieve with an adapter layer. And one is, for example, thread pool management. Akka, as a runtime platform, gives you great tools to configure execution context and dispatchers, and has a lot of well thought out abstractions to make sure that your Akka actors are scheduled properly across all the threads of your CPUs. So this thread pool management is great, and we want to use it in our stack. Now, if we rely on something like NetI underneath, then NetI comes with its own thread pool management, its own thread pool configuration, and you can't leverage what Akka already gives you. And no adapter layer is going to fix that. Same thing for configuration. You can see on this chart there are all kinds of links. If you want to, you can just click through. But Akka uses the Typesafe config, which is a modern way of configuring your application, which is much more usable and nicer than XML configuration. And that's something that we want to use for all components in our stack. If we rely on non-Scala, non-Akka tools in our stack, then we can't use them for these layers, and that's a pity. We want to have unified logging. If you have a large application, then there's a good chance that you produce tons of logs, and it's great to have a unified logging situation where everything, for example, if you work with Spray, is going to be logged to the Akka event bus, which you can easily tie in from Akka and work with the log messages in any way that you want. If you wrap legacy Java implementations like NetI, for example, then you don't get that kind of logging. And then finally, once you have your application built and you want to fix problems or optimize it for performance, then it's also good if you can rely on one set of tools to debug and optimize the complete stack, and not just the top part of your stack. And then for the bottom layer, you might need different tools. Things like the Typesafe console that Typesafe has recently opened up to all developers are great to inspect what your Akka application is doing, how it's behaving, and how you can optimize it. So if this is what we want, then we can't get it by just using existing HTTP implementations. So what we want to build on Akka, and that means our complete application, not just the top parts or a few bits, but everything. And if we apply the same principles, concepts, and coding style in all layers of our HTTP and network stack, then it makes it much easier to find problems, fix them, and tune. This is the reason why we went to the trouble of building a completely new HTTP stack with Spray. So if we look at Spray, then, as you've heard me talking about, it's entirely built in Scala, so we don't wrap any Java libraries. And from the ground up, it's designed as a fully async and non-blocking implementation. So we only block where we can't avoid it. There are a few small things here and there where it's really tough to avoid blocking. For example, DNS name lookups are still blocking, and we're working on fixing this. But apart from these exceptions, everything is asynchronous and non-blocking. And there's only one type of active component in everything around Spray, and that's actors. It's built in actors, it lives in actors, everything is actorized, so to speak. So it really fits seamlessly together with everything else in your Akka application. The core API style is message protocols. So messages are being sent, you receive messages as actor messages. It's very natural when you're working with Akka. Of course, it also this style also helps you with certain guidelines in the Akka world, like tell, don't ask, which you might have heard about, which basically just means rather send messages in a fire and forget manner to your other components, and don't wait for responses. And we can get to that in a second. And then, of course, it's a few of the other principles that underlie the development is performance-based, especially in the low-level layers. Be lightweight, so we really manage dependencies very carefully. And it's very modular, so you only need to tie in the components that you actually rely on. And testability is also very important. So what does Spray consist of? It's, as I said, it's quite nicely split apart in all kinds of modules. And these 4 ones that you see here are the main ones. There is on the side an HTTP data model layer, which it's not really a layer. It's a library that contains everything that you work with when you work with HTTP as a nice Scala model, and we'll get to that in a second. And then you have active components, so to speak. There's a low-level layer called SprayCan, which implements the low-level HTTP server and client, and on top you have specific high-level DSLs, once for the server side and once for the client side. And then there are other components that I'm not going to get to in this talk, which is Spray Surflet and Spray Test Kit, for example, and some smaller things. So as we go along here, we're going to first look at the HTTP data model, then at the low-level SprayCan layer, and finally we're going to look into the high-level server-side DSL. So let's get started with the HTTP data model. The data model, as I said, is a case class-based model that contains high-level abstractions for everything that you need when you work with HTTP. So responses, requests, URIs, headers, cookies, everything you need. It's fully immutable, so there's no mutability anywhere, which means you can send those things nicely between actors. They're serializable, and so on. They can be cached, which is great. There is very little logic in this component because it's a data model. And we also define for you all the common things that you need, like the media types and status codes and encodings and char sets and everything that you just want to have available when you work with HTTP. But it's also open for extension. So if you decide to implement a custom media type, for example, you can just register it, and Spray is going to use your custom types as well. Let's see what this looks like in code. And here I have just shown you the HTTP request model that comes with Spray, and it's exactly what you want basically when you come from Scala. It's a case class, so it's immutable, and it has 5 members, which is the method, which is also not just a string, but it has a proper type because we want to leverage the Scala type system. It has a URI, which is also not a string, but it's also, as we're going to see in a second, an actual type. Then headers are properly typed. You have an entity, which is another type, and then a protocol. So everything is typed. It's not integers or strings. The response on the other side looks pretty similar. It's just the same thing. It's a status code, entity, headers, protocol. And it also extends the same base type, so you can work with both kinds of messages if you need to in certain cases. So the URI, for example, just to double click on that, consists of a string, which is the scheme, but then the authority is itself another type that's properly modeled and that contains the the host as well as the user data, for example, because a URI can contain user and even a password. Then you have a path, which is another proper type, and a query, which you can access nicely, and so on. So you can see that we try to model everything as deeply as it makes sense from Scala, so that you can rely on the compiler and the type system to protect you from making mistakes. We also model the most important header types properly. So you don't have, as in many other frameworks, you don't have a string pair, which is often the only model that other things like other frameworks give you for modeling HTTP headers. But there's a proper type set cookie, for example, and it has a value which is an HTTP cookie. So it's, again, not a string. So you don't need to worry about how cookies are rendered, how they are parsed, or anything. Spray does all this for you. Some of you that don't know Scala too much might be a little bit surprised to see these strange backtick names there, like except-charset. And that's a feature of Scala which is quite interesting, and that Spray HTTP uses quite a bit, which is the ability to use basically any type of identifier as identifier, any type of string as identifier for your types if you set it in backticks, which is great because you can use the HTTP headers here exactly as you would write them as a string. But you don't write them as a string, it's a real type, but it does have the except-charset look like it would have in the actual HTTP request or response. So, and all the other types are exactly the same. And of course, we can't know all the headers that exist out there because you can also make up your own. And that's why if Spray doesn't know the header that a certain message has, it'll just give you a raw header instance, which is the string-string pair, as you can see. And that allows you to still work with fancy headers if you need to. So let's move on from Spray HTTP to the low-level HTTP server and client layer. This sits directly on top of the new Akka IO layer, which became available with Akka 2.2, and which we're going to look into in a second. And it basically just performs everything that's necessary to transform raw TCP data into HTTP, into the high-level HTTP data model that I just showed you. And this translation goes in both directions. But that's all it does. It's implemented as a cleanly separated layer of actors, and it's an Akka extension. And it only focuses on the essentials. So there are no higher level features in there like file serving or everything that can be implemented in a higher level server or client-side component. It only implements what you really need to implement at a low-level layer. For example, timeout management on a connection cannot be implemented on a high-level layer, so it needs to be done in SprayCan in the low-level HTTP layer. So to show you where this fits into the I/O stack, you can see here that basically if you sit on the OS level network stack, which might be on Windows, on Linux, or on OS X, whatever your platform is, there's Java Neo from the JDK on top, which provides you a uniform API that you can use your application on different operating systems. And then on top of Java Neo sits Akka IO, which does the translation of the Neo API into actual actor messages. On top, SprayCan, the low-level HTTP layer, and then your application can either decide to work with SprayCan directly, more or less directly in a raw form, accessing the SprayCan APIs, or you can rely on things like Spray routing, which gives you nicer ways of defining server-side API behavior. So let's take a small side detour into Akka IO, which used to be part of Spray as a module called Spray IO until the beginning of 2013, when we decided to work together with the Akka team and move Spray IO into Akka IO and completely rework it in the process to come up with something that much more people can rely on. If we take a step back and look at network communication, then network communication is ultimately packet-based, right? It's not a continuous flow of bytes. It's packets that come across the network and hit the network interface. it's not. So we have packet switched networks. We don't have circuit switched networks. So this is an important nature of what is happening on the network. Now, if you look at the way that Java I/O before the Neo I/O actually worked, then it tried to give you a stream-based API. So if you wanted to read from the network, you would read from a stream, and if there are no data to read from, then your thread would block. And on the output side, it's the same. If you write to a stream which just blocks if it's not possible to write anything because the send buffer is full or because your client is not reading fast enough. Now, if you look at this, then you see that there's a paradigm mismatch between the stream-based API that Java was trying to show you versus the message-based nature of the network as it's happening underneath. And then later there was Java Neo, which is the new I/O, which is not as new anymore. It must be like 10 years now that this exists. And this extended the API with support for asynchronous non-blocking operations. But as some of you might know, it's incredibly hard to use. And it's hard to use right. And it's still not message-based. It's still not really giving you that view that the network actually has. And this is what Akka IO tries to fix. It bridges the gap between Java and Neo, so it does all the ugly Neo API work for you, and it gives you something that is much easier to understand because it actually surfaces the nature of what is happening on the network. Let's see what this looks like. So here's your application, which might also be Spray. It's just this picture just concentrates on Akka IO as a separate component. So it sits on top of Java Neo. If something happens on the network, then you have an event that comes into your application as an actor message. And on the other hand, if your application sends out commands, they are being sent as actor messages to the Akka IO layer, which then translates it into the appropriate calls on the Java Neo API. So the important thing is that these things are actor messages. For example, the events can be one single immutable message that you receive when a connection has been established, or when a certain packet with a certain number of bytes has arrived, or when the peer closed the connection, just to show a few examples of what kind of events are being modeled as actor messages. And on the other side, when you write to the network, you do this with actor messages that you send to the Akka IO layer. For example, if you want to attempt a connection to a new peer, if you want to send some bytes across an established connection, or finally, of course, if you want to close a connection. And this model is really easy to understand and it's easy to work with. This is what SprayCan, the low-level layer, sits on top. It provides you a message-based API actually on several levels, so you can decide on whether you want to manage HTTP connections yourself. If you want to, you can do that. You can open an HTTP connection. You can fire requests across it as you see fit. But if you don't want that low-level, that really, really low-level API, you can also move higher, and you can just on the client, I'd say, just send a request to this host and give me a future on the response, for example. The guiding principle for this low-level HTTP layer has been maximum throughput with acceptable latency, which is what we are striving for on all layers, and because this gives you the best performance. So it's not so much about minimizing latency, it's maximizing throughput and just trading off latency as it is acceptable. It's built to support massive numbers of concurrent connections, either on the client or on the server side. So there's no reason why your Spray application shouldn't be able to handle 100,000 concurrent connections if you have enough memory and if you have your OS configured in a way that actually gives you that number of file handles, for example. It implements everything, as I said before, that's needs to be implemented at that layer, like HTTP pipelining on the request on the client or on the server side. It's fully supported. It supports chunked messages, so sometimes also called streaming, which is this HTTP 1.1 feature that didn't exist in 1.0. SSL and TLS encryption if you want it. Let's look at some code. How would you use this low-level layer? Suppose you have an actor in Scala implemented like this. Then it should be relatively easy for you to find out what this thing does. So this actor is going to receive a message, a HTTP connected message, when a new client on the server side has connected. And then your application has a chance to register an actor for this connection that handles everything that happens on this connection. So in this case, this actor just registers itself for all connections that are coming in from the outside. And then when a request actually comes in across the connection, the second case in this receive partial function is matched, and you should be able to understand pretty nicely what this thing does. It just reacts to GET requests to the root URI, and it simply answers with an HTTP response that contains an entity PON. That's all. So it's relatively easy to understand, and it feels natural to program in that way. Let's move over to the high-level server-side layer, which is called Spray routing, which might not be the best name because it actually does much more than just routing. And we'll see how that works. So it actually implements an internal DSL for defining the logic that your application layer, that your application API layer should implement. And it's type-safe. It's very flexible because we rely on a nice, sometimes a bit advanced library called Shapeless that you can also click through if you want to learn more about it. But you don't have to worry about all the details there. You can just use spray routing without knowing anything about Shapeless. It does much more, as I said, than just routing, because if you know routing maybe from Rails or from Play, then it's what is often understood as routing is more or less a table that defines which URI paths are being forwarded or channeled to a certain logic block on your application layer. And this routing is something that is part of this high-level DSL, but there's much more we'll see in a second. It relies on small building blocks called directives, which do one thing and can be combined very flexibly to form a very composable structure. And we'll see how that fits in right now. Suppose you have an application core that implements a very complex, very expensive business logic. That's the application that you have been building, and that is where all your value sits. Now, you need to give it many times an API layer so that people from the outside, like your clients, your customers, can talk to your application core. Now, this API layer implements the logic that you use spray routing for. Now let's look what happens. Let's look at what happens when an HTTP request comes in. It basically hits the API layer, which then applies its logic to trigger some kind of action in your application core. For example, suppose you have a very complex application that reverses strings. So you send it an action request which says, okay, I have a very long string, hello, which needs to be reversed in a very complex way. And then your application business logic goes off, does its thing, and then replies with the reversed string back to the API layer, which then translates this reply into an HTTP response that goes out. The important thing here is that the action and the reply are domain objects, which means that they are things that mean something in the context of your application and that do not contain anything that has to do with HTTP. Because after all, your application core doesn't need to know or shouldn't know anything about HTTP. HTTP is just an integration protocol for enabling your customers to talk to your application. But your application itself works with strings on complicated commands and all kinds of things that it needs internally to be able to do its magic. But it shouldn't know anything about HTTP. So the API layer should sit on the side and completely be encapsulated and decoupled from the rest. And it's the job of the API layer to raise the abstraction level from HTTP requests to the actions that mean something to your application core, and on the way out, to lower the level of abstraction from the replies that come back from your application core to something that means something in the context of HTTP. So this means that when we look at what are the responsibilities of your API layer, then we have things like request routing, as I said before, where based on certain properties of the request, certain logic needs to be associated with these types of requests. So based on the method of the request, on the path of the query parameters, or of the content of the request, you want certain logic to be run. And as we've seen right now, there's this raising and lowering the level of abstraction to and from the domain objects, which is called unmarshalling in our terminology. It's also often called serialization or deserialization or pickling or depickling or whatever you prefer. Then there are other things that mean something in the context of HTTP, like compression. You can say, okay, I want my outgoing responses to be gzipped or deflated. You want, many times you need some kind of authentication or authorization, so you need to find out who the customer or the client is that is talking to your application, and you need to find out, is this customer that I now know or think I know, is he actually allowed to access this resource? So this is also something that the API layer should be responsible for. And then many times it's helpful if the API layer, if this layer can just serve small static content like documentation sites or any other things. It can cache responses that are cacheable. And one very important point is RESTful error handling. If you build a REST API and give your application a REST API that customers can access, then it's crucial that your customers get proper error messages if they do something wrong or if something went wrong in your application, because otherwise they're going to be frustrated quite quickly, because many times it's hard to really figure out, how do I use a REST API that some business service gives me. For example, if the business service can only serve, or does maybe wants to serve only responses that are gzipped, and I don't accept with my request gzip responses, then I should be getting an error message that that tells me exactly what the problem is, so that I know, okay, this service only accepts requests that allow gzipped responses. And if the error response doesn't allow you to really figure out what I did wrong as a client, then this might hurt your whole business. So what does it look like? You've seen before how the low-level API looks like, where you work directly with actor messages. Spray routing gives you a DSL where you can just define the behavior. So if you look at this without knowing anything else about the details of the routing DSL, you should be able to figure out quite easily what this thing does. It reacts to requests to URIs that go to /order and then contain after the slash some kind of hex integer number. And this matcher here that matches hex int numbers does more than just simply extracting this. It also does range checks. It makes sure that the number that someone has put in here really fits into 32 bits or 31 bits, and it gives you proper error messages if something goes wrong there. And then when such a request comes in, this hex int number is being extracted as an int, and the block inside of this path directive can access the ID. And there are two types of methods defined here. GET requests are being served differently from PUT requests. And you can see that in this case, the logic is not that complicated. It's just completing the request with one or the other string, as you can see. So the important thing is it's type safe. So the ID up there is an int. You don't have to write it down. It's a compiler can figure it out by itself that it's an int, and you can access it as an int if you need to. So these directives, this is just the list of directives that are part of the current RC3 that we have released last week. And there are actually more than 100 predefined directives that you can plug together more or less freely to define your own logic. And they define all kinds of things that you probably need or might need in your application, like logging, like future handling, where you create some kind of futures, and you only want to continue with the request logic when this future is actually filled with a value. It has everything from working with extracting request headers or header values, working with cookies, and so on and so on. Obviously, I'm not going to go through all those 100 things. I just wanted to show you that there's already a lot of logic predefined for you, and you can just rely on it. So here's one real-world example that we have taken from and sanitized from a real-world client. And I'm not going to go through everything in detail. I just wanted to show you what it looks like when you write a service description with Spray routing. And this service is quite complicated. I can scroll through here. You can see that there's quite a lot of stuff there, but it's all very readable and should be easy to understand for you. So let's quickly start. There's, for example, out here on the outermost level, we have something called encode response gzip, which just says all responses that come back from the service should be gzipped. And it also says implicitly that if the client does not support gzip encoding, then he or she is going to get a proper error message telling them exactly what went wrong. So inside of this, we have this selector that just says, okay, if the path is just a single slash, so if it's the root, then we want to serve GET requests with a redirection to /doc, which just gives back, in this case, a 301 response to the client, which is a redirection. So then we have all requests that start with API, go in here. We do JSON P, which is already supported by Spray with this parameter, and then /API/top articles responds to GET requests with the logic in here. We extract a query parameter which needs to be called max and which needs to be an int, and this is then the int that we have extracted from the query parameter, and then we do all this in here and so on. This parameter directive here, once again, makes sure that if the max parameter is not there, the client will receive a proper error message. And then we only respond to those things if max is actually greater than 0. And what this does, this is quite interesting. It takes the max and sends it to another actor. This here, you might know it is an Akka ask, which means send a message to another actor and give me back a future for the value that the other actor will respond to. So whatever comes back from this actor eventually is going to be, it needs to be a sequence of article. Article is some kind of business domain model here. And this complete call then completes the request with this sequence of articles. Now, as you see, this article is a domain model, so it's a case class that defines something in the context of my application core, and the logic for how these things are then being translated into an HTTP response doesn't show up here. It's defined somewhere with a marshaller for article, which is being tied in through Scala's type system by the use of type classes or implicit parameters that we are not going to look into details. But it's great because you can define completely separately how articles should be rendered into HTTP responses without the need to dirty this description with this logic. So then you can see this goes on here. This path, for example, requires certain types of authentication. This thing doesn't exist. This is a directive that the client has written itself, which is really easy. And then you see certain requests to ranking. GET requests are actually being counted and timed. This is also a custom. There are all kinds of parameters being extracted. This thing requires. It doesn't really require them. You can see they are optional and they have a default value if they're not there. And then it does the same thing that we've seen before. It sends off a domain message to another actor, expects eventually some kind of result that is being used for completing the request, and so on and so on. Here you can see here's authorization. Post request can only be done by users that have that are admins. This is once again defined by the client. It actually deserializes the entity content of the request in this high-level account details object, and so on. This is the same pattern that you've seen before. Let's go down here. This is something interesting. Apparently this API has some kind of version 1, which is not implemented in Scala, but it's actually implemented in another language in a Django server. And what this client has decided is to simply forward all requests to the old version of the API to Django just by proxying, which is easy to do with Spray because, as I said in the beginning, Spray implements client as well as server-side components, which makes proxying really easy. All you have to do is to forward the incoming request that is incoming on the server side as an outgoing request on the client side to the old server. And since the request model for the server and the client side is identical, this is really easy. If you don't have this, for example, in a servlet container, it's not as easy because the model that comes in, the request only exists on the server side, and there's no client-side implementation in the servlet API. So just proxying this to another server is really, really difficult. You would have to use something like async HTTP client or some other tools, and then do a manual translation of the model of the request as it exists on the servlet API to the model that exists, for example, in async HTTP client. So there's more here that we could talk about, but let's just move on because we want to give you a chance to ask more questions. What are the best practices? One really important thing when you work with Spray or Akka, for that matter, is you shouldn't block. And you shouldn't block in your routes, because blocking would actually waste the thread that is currently executing a request and prevents it from being able to execute all other requests. So as long as you don't block, the performance is going to be quite nice. If you block, then you might see problems in all kinds of cases. It's also good to keep your route structure clean and readable, as we've seen before, because then it's easily maintainable, and you will be able to, even half a year from now, you will be able to understand what your API logic really is, because it's split apart in really small things that are plugged together, as we've seen. One thing, don't let the API layer leak into your application. As we've seen in the architecture overview before, your application shouldn't know about anything HTTP. So it's usually best if you create a separate model for your API layer, and you have your API layer depend on the application core, but not the other way around. Then if you use the marshalling/unmarshalling infrastructure that comes with Spray, this allows you to write your API code really nicely, as we've seen before, and it allows you to tie in this serialization logic with type classes through the Scala compiler, which has all kinds of benefits. And then finally, I want to point you to an SBT plugin that we have also made available, which is called SBT Revolver, and which gives you a very fast development turnaround. It can basically restart your application in the background when you change the code. And this can give you a very, very nice way to test changes very, very quickly. You can also combine it with something like JRebel, which is able to even reload changed classes into your running application without having to restart. So for large applications, this can be a great time saver and productivity feature. There's more that I could talk about. There's Spray Servlet, for example, which, just 2 words, is a small module that enables you to run Spray routing, so the high-level server-side DSL, also inside of a servlet container, because we know that it's not always easy to start from scratch. Sometimes you have to use existing infrastructure, and then Spray Servlet lets you use the nice features of Spray routing, even if you're still stuck in a servlet container. I could talk about request or response streaming, or how you are able to test your routes. We have a test kit that enables you to test your routing structure without having to fire up actors. So you can really do very fine-grained tests, which is very valuable and important. We haven't seen the client-side APIs. There's something that we could get into, but I invite you to check out the documentation for that. And there's JSON support and all kinds of other things. What's the current state? Basically, we're currently in the last rounds of the 10.11.12 final. It's a triple release. RC3 was just released last week, as I said. We're going to release another RC probably tomorrow. We do a triple release because Spray currently targets 3 different Akka versions. So you can use the current version with Akka 2.0 and Scala 2.9, or Akka 2.1 and Scala 2.10, or Akka 2.2 and Scala 2.10. So whatever floats your boat or wherever you're stuck, we have something that you can use. After the final, as some of you might have read, Spray will become a part of Akka itself. It will become a new module called Akka HTTP. And then sometime next year, Play will gradually move over onto the new Akka HTTP, so that Play as well will reap in the benefits of what we've just talked about. And then, of course, there are other things and rounding off and features coming in. If you want to get started, I can point you to this to our site, Spray IO. There's also a mailing list which is very active, tons of very friendly and helpful users there. So if you have a question, don't hesitate to contact us. We'll also respond happily on Twitter if you follow us. So whatever channel you would like to use, we try to respond. And then I think we're done with this part of the hour. I hope we have some time for a Q&A. Yes, maybe, James, do you have some questions for me?
We do. We've had a lot of great questions come in. So let's start at the top here. So how is Spray going to change in its transition to Akka HTTP? Will the programming model change significantly?
Yes, that's a question that we have that we see quite a lot, because lots of people are already using Spray and are worried about everything breaking with the move to Akka HTTP, which is completely understandable. The guiding principle when we move Spray into Akka is not to throw everything up in the air and change everything around. We will try to keep everything as stable as it is right now. So we'll certainly apply some improvements here or there, but there's no change planned in a basic, in any of the basic structures. So the APIs will stay largely the same, and you will definitely be able to recognize Akka HTTP after the transition. And we will also make sure that we, better than we have done in the past, which we have to admit, to give you proper migration support. So you should have a very good guideline for how you move your existing Spray application onto Akka HTTP. So generally, don't worry about it. It shouldn't be a big problem.
That's great to hear. So next question is, how do you deal with the fact that actor messages do not have guaranteed delivery? Do you have some kind of low-level hacking, or just hope for the best?
There's no guaranteed delivery, which is part of Akka. So Spray doesn't really introduce any new concepts. It sits on top of Akka and it leverages everything that Akka gives you. So of course, there's no guaranteed delivery in Akka, and there are all kinds of great resources to read why this is the case. But you can use hacking. Basically, the answer that's the only one that makes sense is if you need guaranteed delivery or something like it, then you should just use hacking. So you send a message and you just expect an hacking response, and Spray allows you to do just that. So if you need hacking, you can do it. You can send a request and you can ask SprayCan to answer with your own hack message that you're going to be receiving when everything went all right. So this is, for example, also important in order to be able to implement back pressure. If you serve, for example, a large file and the client is kind of slow, then you need to make sure that you don't overwhelm your client with data. So that means if you use hacking, you can only feed the network with whatever it is able to consume, and make sure that you automatically make use of things like TCP flow control and so on. So hacking is supported and is one of the core features that is important in order to be able to properly work with Akka or Spray for that matter.
That's great. So there's a question about, are there any customers that you can reference that are using Spray for web or iOS backend, iOS application backends?
Yes, there is actually a page on Spray IO that you can check out. If you go to, I think it's called Project, there's a page called References where we list all kinds of companies and organizations that have been so kind to inform us of they are using Spray. We have a few really big customers that do not want us to mention their names in public, But in general, it's of course for an open source library like Spray always sometimes a bit hard to find out who exactly is using you. We see lots of questions on the mailing list from many corporations and organizations. But if you are using Spray and we don't know about it, then just let us know. We'll be happy to put your name on our reference page and also mention interesting things on our blog or wherever. So let us know.
Great, thank you. So next question is there a way to plug in a different JSON marshaller and unmarshaller?
Absolutely. So Spray does have something called Spray JSON, which we developed also I don't know, 2 years ago or something, when the JSON landscape in Scala was much less busy as it is now. So we know that there are tons of JSON implementations in Scala, and you can use whatever you want. We're not tied at all to Spray JSON. There's even support built in for Play JSON, for Lift JSON, for JSON for S, so you don't need to write the marshalling or unmarshalling layers yourself if you use any of these three, but it's really easy to just plug in whatever serialization or deserialization library that you want to use, so it's not at all dependent on Spray JSON.
Great, great. Let's see, there's a question here about, someone says, I've seen the tilde operator in Spray and Specs and other Scala libraries. What does that mean in the context of Spray routing?
Yes, if you look at the example, let's go back actually. We can just check it out here. So here's a tilde operator that this question concerns. What this does, it's basically just tying this expression together with this expression. So this is a Scala expression returning some value, and this is another one. And this here is actually a method call that combines this one with this one to give you a combined expression. If you leave this out, then this here will be a statement, and it will be run, but the return value will just be lost. So this is a necessary thing for the DSL. You'll also see it in Specs or wherever, in order to give you something lightweight to connect two different expressions in a way that that allows you to see a combined result. So it's nothing special. It just needs to be there in order to satisfy the Scala DSL infrastructure.
Great, thank you. One last question before we wrap up, and I'll say that we weren't able to get to everyone's questions. I'm sorry about that, but we will respond to you with an answer or with some way to help you out if you didn't get your question answered. So with that, the last question is about WebSockets, and what do we do about server push and WebSockets?
Yes, WebSockets is also one of the questions that we get a lot. If you there's a ticket, there's a very long-standing ticket on GitHub for WebSocket support, and there are already, I don't know, 100 people or something who have added their +1 under this ticket, and if you want, you can just go there and add another few +1s. So we know it's something that people desperately want, and we know that it's important. It will become part of Spray. It has to become part of Spray because Play needs it. So we will implement it as part of Akka HTTP before the transition of Play onto Akka HTTP, because otherwise Play can't use it. So it will come, but it's not part of the current release cycle, just because there are so many other things that we've had to concentrate on, and it was just something that is not yet available, unfortunately. Even though there has been contributions on the mailing list, if you check the mailing list, you will see that some guy has put considerable amount of work into making WebSockets available for Spray, and there's a fork that you can use there. We haven't really looked into it too much, but as far as I understand, it's usable. So we're also open for contributions on that end. Come talk to us on the mailing list.
Great. Thank you so much, Matthias. Thank you all for attending. You will all receive the recording URL once we get this up on our YouTube channel. So thanks, Matthias.
Thanks a lot,
thanks
James.
everyone for attending.
Yes, great. Goodbye.